Another variation of reaction stoichiometry is when you have to find a limiting reagent. This is when you are given two knowns. So you've got too much information and you have to find out which reagent is going to run out first. To give you an example, I'm going to make ham sandwiches. Now, to make a ham sandwich, it has specific requirements. You need 2 slices of bread and 1 slice of ham. How many ham sandwiches could you make with 3 slices of bread and 1 slice of ham? Well, of course, you can still only make 1 ham sandwich because we won't have enough ham to make more than one. So in this case, the limiting reagent is the ham because it prevents you from making more than one ham sandwich. The excess reagent will be the bread because you've got some left over. So how many ham sandwiches could you make with 8 slices of bread and 5 slices of ham? Well, we all know that each ham sandwich needs 2 slices of bread. So 8 divided by 2 is 4. But we've got 5 slices of ham. So we only need 4. So in this case, you would have the limiting reagent would be the bread, and the excess reagent would be the ham, because you're going to have some ham left over at the end. So let's introduce some terminology. The limiting reagent is the reagent that is used up in a chemical reaction. There'll be none left at the end. The excess reagent always has some left over at the end of the reaction. Let's look at how you can calculate involving a limiting reagent. We're going to have a variation on our previous method. We still need to find the data. We still need to write a balanced chemical equation, but this time we've got 2 knowns. So we've got too much information. That's how we identify the limiting reagent. Question. Now we have to determine the limiting reagent, and we do this by using a balanced chemical equation. Once we've done that, the limiting reagent becomes the known, and we use this known from now on. We can then use the balanced chemical equation to find the moles of the unknown, and then we can find the mass of the unknown. Now, like any other stoichiometry, the first thing we're going to need to do is identify the data. We have 10 grams of sodium hydroxide. It's added to 15 grams of copper sulfate solution, and we need to find a mass of the precipitate. So we're going to start by writing a balanced chemical equation. The sodium hydroxide is added to the copper sulfate. It will give us the copper hydroxide, which is a precipitate, and our sodium sulfate. It needs balancing. Like any stoichiometry, after we've got our balanced chemical equation, we have to find them from the mass known, we have to find the moles known, and we do this by using number of moles equals mass over formula mass, except this time we've got 2 knowns. So let's find the moles. The number of moles of sodium hydroxide is equal to a mass over a formula mass. Please notice I'm telling my marker what I'm doing. So 10 grams divided by the formula mass is 39.998, which I get it off the periodic table, is equal to 0.2500 moles. Now I'm going to store that in my calculator. The number of moles of copper sulfate is equal to a mass over a formula mass. The mass was 15 grams divided by 159.62 grams, which is equal to 0.09397 moles. And I'm going to store that in my calculator as well. Now we need to find the limiting reagent. Now the easiest method to do this is just the pick and choose method. Let's try one out. So I'm going to pick sodium hydroxide. So I'm going to give it a go. I'm going to use my balance chemical equation to find out actually how many moles of copper sulfate I need if I use up all of this sodium hydroxide. So I go, the number of moles of copper sulfate would equal the unknown over the known times the moles of sodium hydroxide. So the unknown would be 1, the known would be 2, times 0.2500. And this comes out to 0.12500 moles. Now I need to ask myself a question. Do I actually have 0.125 moles of copper sulfate? Now looking back here, I've only got 0.09397 moles. So no, I don't have enough moles of copper sulfate. So the copper sulfate in this case is the limiting reagent. Now that we know what the limiting reagent is, our moles known becomes the copper sulfate. And we must use the copper sulfate from now on to calculate the moles of the unknown. And remember, we do that by using the balance chemical equation. So now that I've got my moles known, which is the copper sulfate, I can now go ahead and find the mass of the precipitate by finding the moles unknown of copper hydroxide. So the number of moles of copper hydroxide will equal the unknown over the known times the moles of the known, which remember has to be your limiting reagent. So in this case the unknown was 1, the known was 1, so times 0.09397 moles. So the answer will be 0.09397 moles of copper hydroxide. So we're here now. We've got the moles of the unknown, and now we just need to find the mass of the unknown. And we do that by using mass equals number of moles times formula mass. Now we're ready to find the mass of copper hydroxide. Equals number of moles times formula mass. So the number of moles is 0.09397. We go to our periodic table to find out the formula mass of copper hydroxide, which is 97.566. And we get an answer of 9.17 grams. Remember, we've got 3 significant figures there and 3 significant figures there. So my answer must also be to 3 significant figures. Now it's time for you to try some yourself. You need to go to the OneNote, Chemistry Calculations Limiting Reagent. There's a couple of examples. Try them. Then you can check out the YouTube video. I've put them on space. And here are the web links.